Okay, everybody, we're going to get started with our next session. Please take your seats. So when I started talking to Scott Reinhardt about this project and what we wanted to accomplish today, Scott wanted to make sure to bring in some of the key technology partners to offer up presentations on how their technologies specifically fit within the Campus Crossroads project. So we have part one of this conversation. And we have 4 presenters. So the way this is going to work is they each have a short presentation that's really focused on how their there's no sales pitches, from what I understand. So, I mean, yours is a little different because you're not talking about a technology per se, correct? So we're going to offer up their role within the project specifically. It'll be about 5 minutes, hopefully, each. And then we'll have some conversation and some questions. If anybody has a question after a presentation or during one, please just shoot your hand up and ask away. So up first is Brendan Cline. He's with BeckTV, Systems Engineer and Project Manager. So please welcome Brendan Cline.
Thank you, guys. So yeah, my title is actually Project Engineer because I think I'm on. You hear me? Which is sort of a hybrid. So the way Beck works is we have one lead engineer that also does project management and does client interface. So I got on this project 2 NABs ago, basically, and talked with Scott on a weekly, almost daily basis for a very long time once we became the integrator. And we had a design that came from the consultant, from WJHW, and we had to make decisions on what technology was actually going to go in and piece together the design that and the vision that they had that came through the bid that we won. So let's talk some technology, right? That's why we're all here. Gotcha. So what was our objective in this project? From our standpoint was we wanted to make a production facility where we could produce anywhere on campus. So in a way, it's a lot like having a remote production space. I kind of think of it more as a campus production space because you get a little extra fiber for what we're doing to run cameras back. But we also have remote fly packs and wireless fly packs that we're trying to interconnect. At the same time, we're trying to use technology that is on the cutting edge that's going to future-proof them as they grow. And a lot of that comes down to what we're seeing in the IP space with SMPTE 2110 coming and probably going to be a pretty dominant standard that everybody's going to use. Really wasn't a viable option at the time we did the build, but we wanted the parts and pieces to be able to upgrade or integrate to that as that became a standard. So we chose those pieces based on that. The keys to the design. I've worked with everybody that has sat up on this panel pretty extensively. There's a fiber infrastructure team. You saw Rick Mock up here. The IT team, Ron, Dan, Scott. We had to work together to make this very difficult project work because everything was new. It was different. It wasn't just putting in a baseband router and saying go. It was tons of switches and figuring out how to time things in a world that you can't really test in a legacy way. So the keys to this is we had a fiber infrastructure, and that's around the campus, and it's also within our production space. We use an IP video router, which connectivity is fiber-based. And then our audio, which was a challenge as well, we have Dante, but we also have a lot of AES-67, which Martin will talk about when he does his presentation. We wanted to use AES-67 as we move towards SMPTE 110, if that became a viable option, where we have a big pool of audio where you can just share, right? And that was a key in making a couple decisions with going with Riedel and going with Telos Axia for our mixer. And then finally, something that we fought this entire time is timing. We used to just run blackburst everything or tri-level, and we'd have these pulse signals and everything would time. It was real easy. Now we're timing in a lot of different spaces. We're timing within the router. What we use in the router is Aspen. because that's really the viable option that we had at this time, and that's an MPEG-based transport stream. So they use a PCR timing. The audio uses a PTP timing, and then there's a lot of native devices that are still going to use blackbursts. So I found a program online to do a little high-level drawing. Once I worked this up, I told my my document specialist who does all my as-builts, I said, no need to do any more drawings. I've captured the entire system on this slide here. So, you know, we have a master clock that gets GPS antennas, and that provides us all of our sync. And that's pulse, that's PTP, and that's PCR. Those feed into a giant stack of network switches. I spent a lot of time with the IT guys here, Bob Richmond, Mike Atkins, deciding what switches we were going to use. There are, you know, approximately 100, maybe 120 devices that are requiring PTP timing to figure out their delay and to make sure that we're syncing up with anything that we're doing with video. That's a lot of payload to put on the master clock to handle all that traffic. So we ended up using boundary clock switches, which take the master clock and protect it. And then it becomes the master to all the slave devices that are going to live off of that switch. So we put in some Cisco Nexuses to do that. That's what all this audio is hanging off of with Riedel and Axion, and it's worked pretty good. We also, because of our router is agnostic as to whatever signals can go through it, we're running a lot of Aspen through that, but we're also doing just IP encapsulation. We're extending network like you would with a media converter, and we can route it around and put it out in the field. So I can get a VLAN that lives on a switch in my core. I can run it through a network fiber gateway that they have and route it out to a remote kit. So I can plug in a Dante device or an Axion device based on what I need on this port. The top right of this, where you have these SDI to Aspen gateways, there's not enough gear right now that has got fiber connectivity right off the back, where you don't have to go baseband. So there's still a large portion of this design, although it's IP-centric in the core, your endpoints still are physical BNC connections. We still have patch panels here, which, you know, we needed really, you know, at this stage in the game to make sure that our signals were good. So these SDI to Aspen gateways, we had a whole bunch of them. They're all over the place. But we were able to put them out at venues. So we were able to extend our router to, you know, Compton Ice Arena to feed trucks or take cameras from the truck. We were able to do that at Joyce. We do it at the truck dock. And so essentially our router is an extension of a bunch of satellites, similar to what you would see through mixers through the year, where they would have satellite I/O for audio. We're doing that with video now. We did run into a hiccup at one point where we realized it was a little hard to transport to our remote kits using Aspen with the devices we use. So we did have to flip some to SMPTE 2022 to get signals out and back from remote kits and our wireless cameras. But this is essentially your entire system right there. Fiber infrastructure. This was real big. Originally, Scott and I, you know, the plan was, you know, based on the RFP was, you know, we were probably going to have somewhere around 200, 240 fibers that were going to get trunked into us from campus. Well, that grew to, let's future-proof this and allocate fiber for every venue that we're ever going to have to produce something out of. We're going to say 48 fibers to every venue. Those fibers don't exist. But what we're going to do is we're going to run a big trunk, and we're going to run it from in our room to, you know, 100 feet away. They have fiber distribution room, and we were able to do that with MTP cables, which is 12 fibers in a jacket, and we just plug them into cartridges on both ends, and they break out, and they give you the individual duplex connections or SC connections, whatever you're using on those ends. And we have, and that's been a massive management task during this project is, okay, well, now we need to get to this building, and now we need to hit this room, and now we have to produce something over here. And it was really more of, okay, I just have to allocate the ports. We have to break it out to make them easier to use. So if it's a camera connection, we go to a camera connection optical con. If it's an a rattler or something like that, we would go out to an ST. So they're not digging in these dense fiber tubs to do it. But all I'd have to say was, hey, Rick, can your guys hook up, this building to these 3 ports in my room? And they would just do it. And it would be done within a couple days. And that was really crucial as this job went along. Obviously, we do this within our core also. You can see the back of our router is run with MTP. Looks pretty clean, makes it far more efficient. I think we had something like 324 ports, and that's all of them right there run on MTP cables. The KVM also was a fiber connectivity KVM. So anything that was extended, we have KVM that you saw up in level 9, where Mike produces the show. There's KVMs up there, and all they do is they put a console unit up there or a computer up there, and they hook it into a little transmitter or receiver and just run it all the way right into our KVM. There's no conversion. There's no extra stuff doing that. And that's with a G&D KVM system that we had. You're going to get a lot more about the IP router from Vince, but basically it's Aspen, so you get essence routing of being able to de-embed audio and data. We have to do this. We have to shuffle audio, so all the audio that we want from any of our video comes and gets de-embedded and gets put into an audio router that reshuffles to virtual sources as we do records on Dreamcatcher or something like that, so you can get your record melts. But it also, Evertz worked on a special product for us to take that audio and put it right out to AES-67. And we have about 350 streams, I believe, right now that go and feed Axia that they can just suck off the multicast address, and it shows up on the consoles. And then they feed back that AES-67 to us, and that card that they designed for us brings it right back into our router, and we can use their mix and put it on things. There's a lot more information there. You can probably find me separately, and I'll be happy to talk about it. The system was designed to be a 3G system, although we launched at 1080i. We wanted it to be, if you ever go 3G, you don't have to do extra cable pulls. So every SFP in this design, every fiber in this design is designed to carry 3 3Gs one direction and 3 3Gs the other direction. So at whatever point they're ready to do that, if they want to do HDR or they're ready, just to move towards that new future, they can do that without really having any problems. If they start doing 4K, you got to go 3G, obviously, as well. As a designer, we've been doing baseband routers for a long time. It's very simple for us to just do an I/O layout, and we'll say, okay, we have 144 inputs to our router. Here's my source list. Do I hit DAs? Yes. And so we have spreadsheets that are just very generic that we've used for, Beck has been using for 20, 30 years. We got to this and we're like, well, how do we present this information, because we have multiple signals on a single cable, and they're bidirectional signals. So how do we make a spreadsheet, or how do we design this? A drawing doesn't do it justice anymore. You can't figure out my IP gateway has 18 connectors. It could be 9 by 9, but it could be 0 by 18. It could be 3 by 15. And it's all about the number of SFPs that you have in it and how you design it. So we spent a lot of time figuring out how we were going to design the IPGs and present this information to Evertz so that they could program this in their router, and also indicate what's going on every SFP that goes into the router, and still capture our name set and capture what signals are happening here and happening there. That was a pretty fun development that we had to go through to figure out exactly how this was going to lay out and be efficient. You want to be able to get, if you have a 0 by 18 IPG, you're using 6 SFPs, but you have 6 fibers on the back end that are dark. So ideally you want to do a 9 by 9, because then you get 3 by 3 on every SFP, and you only need 3 SFPs. You try to design that way so you're maximizing your bandwidth. And that's sort of the approach that we used when we did this. Audio over IP, Riedel is all AES-67. They use unicast to their panels. We also pulled an audible at NAB when we saw the Bolero wireless intercom that they were displaying there, and Scott and I, we originally had Radioactive, which is excellent wireless intercom. But the Bolero was basically putting a intercom panel on your belt pack. So we thought that would have been and it was AES 67. It integrated perfectly with what we were doing. So we put a full court press on Rick and his team and said, we need these and we need them now. We're in the middle of building this. I got to change my design, but this is the best thing we can do. And it is probably one of the coolest things that we have in this system. It is outstanding. We can put antennas anywhere in any venue, and the belt pack just locks to it when it goes to it. Their time with PTP, as well as Axia's stuff, they have their own format, Livewire, which is an underlying AES 67 format, but can use AES 67 from whatever device. We can share audio between Riedel and Axion and with Evertz and their card, and their time with PTP as well. And last was system timing, and I've been talking about this a little bit already, but this was hard. You know, there's an Evertz guy said it to me early on, is we're still trying to get video to route. And he said, well, just wait until you have to time it all up with all your audio. And I didn't really understand what he meant at the time, but when you encapsulate and decapsulate, as we all know, I mean, we're seeing IPTV feeds to these monitors, and you can see there's a delay in any time you do that. These are very low latency captures on these IPGs, but it's still a capture, and it's still a decap when you come out. So if you have a camera that goes through one of these and comes out to a switcher, and the switcher comes out and goes into another one, and then you send it out somewhere else, you're causing lines of delay or maybe a frame delay. And if you have audio that's in your mixer immediately, you're going to have a lip sync. You're going to have a lip flap issue. And we've had to put in a decent amount of effort for all of our scenarios to make sure that our audio is timed with our video in every place. And a lot of that happens on the IP end, on the IT end. And I still just love being able to plug Blackburst into something and have it lock in, you know. One of the cool things about the EXE that I really did like is that we didn't really need as many frame syncs as you normally would, because everything that comes out of any IPG is locked. So everything that we sent into our switcher was already locked, regardless. You know, you're trying to take feeds from the trucks, and the legacy way of doing that is you have a stack of 30 frame syncs, and everything they send in, you convert to your stuff. We still use them because I think that it gives us comfort. You know, we're not doing up, down, cross, but we are locked with everything going into our switcher if it's a wild feed that didn't have reference, which is kind of cool. And that's pretty much it. That's the whole design that you guys got there. But I did want to echo the amount of effort that every single vendor, and really this has been the best team that I've ever worked with on the client side. Scott has been wonderful. Dan has been wonderful. The IT guys can be difficult, and these IT guys were just, I don't know what you do, but if you sit with me and tell me what this PTP thing is, we're going to work through it. And we did, and every day I would be like, okay, I got a new problem. I need you to come down here, and we're going to figure this out, and we're going to Wireshark it. And it was a really impressive feat to get this to happen in the middle of a construction site for 5 months. So that's it.
Excellent. Thanks, Brendan. So, Martin, we're going to do a little bit deeper dive into some of these technologies here. I believe your slide's next, so let's see.
Almost there. One, two. Ah, here I am.
Give it one more click. Let's see what happens.
Oh, maybe I did. Video problems. Ah, there we go. Thanks.
Thank you, Jason.
I'm Martin Dyster. I'm VP of Business Development for the TV side of Telos Alliance, and I should just start by introducing who Telos Alliance are, because many of you probably won't have even heard of the company. But Telos Alliance is a company that formed out of Cleveland, Ohio, and in 2003 launched the first audio over IP protocol into the market, and we've been a well-kept secret to the TV industry, I think. My job within the company, having come in from a systems integration position, much as similar to Brendan, was to look at the product line that the company has and figure out market strategy to take us into the TV world. And what happened with the Notre Dame project, I understand, if I'm thinking back correctly, a couple of NABs ago, some of the guys from BeckTV came onto our booth at NAB, looked at the products that we had, and something clicked inside and said, okay, we have a project going on at Notre Dame, and this is going to be a great fit. So we didn't really have to do any kind of sales job on that. In fact, all kudos to Brendan and the team at Beck, and Fred particularly. Yeah, they chose us. So we're very proud to be part of this project. So our brief, Brendan's covered a lot of it, but the most important thing for us was to provide a fully compliant AES-67 system, the background of the audio production solution at Notre Dame Studios. Our products are AES compliant out of the box, so that wasn't hard. We're arguably ahead of the curve when it comes to audio over IP. The equipment, as you'll see when you go around the tour, include the production consoles, monitoring devices, audio interfaces that are in the remote kits that convert baseband audio, microphones, headphone feeds back the other way into IP and make them available to the consoles or to anywhere else or to the monitoring systems without going into any kind of core TDM router. Everything's done in the IP domain. And also we did some work with the guys from Ross who provided the Vision switcher to provide some audio follow video console automation, which was one of those workflow project elements that came up during the course of the install. I don't think it was something that was foreseen, and there were a lot of times when that kind of thing happened. Going through interoperability tests with our friends at Riedel and Evertz was part of the project fairly early on. We engaged very early on at an R&D level with guys in Germany and in Canada to make sure that our various pieces could talk to one another at an elemental level. So I mean that really meant sending equipment to Germany, sending equipment to Canada, and putting our support guys together and making sure that these things really are going to talk to one another. And that was a really important part of it. You can do all the interoperability tests and say as much as you like. These kind of camps and things like that, where Ames and the other companies have got together, but to actually do something in a lab that's focused towards a project is another step up, and we were part of that. And as I say, our support team worked very closely with the guys at Beck and Notre Dame. In fact, our two support guys, Brett and Jeff, are the real stars, and probably one of those should be up here telling this story, because they're the guys who really worked right at the coalface. So this whole facility, as far as I'm concerned, I don't think anybody's built a facility like this anywhere in the world. I struggle to think of one. People have dabbled with audio over IP, well, with IP solutions, media over IP, but I don't think anybody has quite gone to the extent. You know, there are projects out there with islands, but there are very few projects that truly encompass everything that IP can do in the way that this project does. One of the most difficult parts of this, or the most iterative parts, I guess, was understanding the workflow, and that was something that we learnt as a company as we went along. So we had, it says on the board there, product firmware updates going on. We had continual work with our software teams, making the products fit the customer requirements as they were understood, and obviously leaping over unforeseen technical hurdles, as Brendan so eruditely stated. IT requirements were one of the big ones, handling QoS and understanding it, and the different ways that related to an IT system, handling multicast without flooding the network and taking everything down. All of those kind of things were things that we had to work through between us as vendors and as systems integrators. So I'll move on to the specific products very quickly. So that's the Axion Fusion console. There are two 28-fader Axion Fusion consoles in the audio control rooms. For guys out there who know the way around the audio world, you may not have heard of Axion consoles, but there are over 7,000 of them installed around the world. The vast majority of them are in radio installs, but there's quite a few in TV as well. And that may be the reason you haven't heard of them, because they're more familiar to the radio space than TV. They're fully compliant. They don't have any audio going to the console surface itself. The Fusions that are installed here have DSP engines that handle all the AS67 streams and do all the things you would expect them to do to mix audio and to compression limiting, all those kind of things, EQ, etc. And all the interfacing with Evertz is just done at the network level. As Brendan said, 360 or so streams are available to either of these consoles that can just be called up on the faders as predetermined profiles. The next important piece are the XNodes. XNodes are audio over IP to baseband interfaces. So they convert analog AES, even SDI, but not in this particular install, and even handle GPIs, convert those bidirectionally to AES67. You can install them anywhere in the system, and any audio that's presented on an XNode is available on the console, and therefore also available to the Evertz system as well. So I noticed one of the remote kits behind us here, there's a little rack down here, has got one of these XNodes, and presumably these microphones are being converted back to IP and taken back to the control rooms as I speak right now, and that's going through XNodes. Axion Rack Selector, that's the small console on the left, the rack mount console. That's being used in the production control rooms as a monitor selector, selecting audio to the main control room speakers, and in a couple of other positions for some ad hoc mixing. The X Selector, the one on the right, is an audio over IP confidence monitor that's being used in a number of positions that you'll see on the tour. And like all the other devices, they're all natively AES67. And they just work within the network and can pick up any audio stream. No patching, no baseband routing, everything available as a source or a destination. And then finally, the other part of the last part of the jigsaw puzzle is the Pathfinder mezzanine software layer. Its role in this particular install is to recognize any AES67 streams on the network as a source or a destination, and create a virtual routing layer that can be controlled as you would control any other router. Its primary use here, though, is the audio follow video function with the that's being used with the ROS switcher. So it's taking commands from the ROS switcher, and it's using those to create crossfades. As I understand it, the use case is when the production goes in and out of a junction with NBC, it fades down the studio monitors automatically as the vision switcher cuts over, and then fades back up as you go out of the junction. And that's about it for the Axion products. Brendan said a lot about the system, so I don't need to do it. And I'm sure there'll be more questions later, but also you'll see a lot of this stuff in operation on the tour. Thanks.
Thanks, Martin. Rick, you're up next to talk about the Riedel.
Excellent. Let's see where we are here. Okay. So my name is Rick Seegull with Riedl Communications, and I manage a team of system consultants for Riedel. So my job here is to interface with the consultant, with the integrator, and with the end user here at Notre Dame. And it really took pretty much a year of talking and going through the design at every single level with those three players. So you guys are all familiar with Riedel, so I can skip through that there. We are real glad of adding Notre Dame to our long list of clients here. Our part of this is the Intercom system, And what we needed to do here was to satisfy three main components that Scott and his team were looking for. And number one was flexibility. As you hear everybody in these different panels speak, it's not just about football here, it's about basketball, it's about soccer, baseball, fencing, and they needed to be able to not only satisfy the requirements for all these different venues, but also be able to take each of these venues and the production staff and move them from one control room to another control room seamlessly, and also allow the people that are involved in those productions to feel at home as they move to these new locations. So that was a very big requirement. Number two was everything had to be networked. It had to be on a layer 3 network. And number three, it basically needed to be future-proof. So as we talk about, and as I discussed with Scott, what his needs were and what his wants were, it not only had to satisfy, you can almost call it the first phase, what we're doing now, but we also needed to look towards the future and make sure that the different standards that come down, SMPTE 2110, that we can easily satisfy the requirements for that as well. So the products that we used here was our artist system. And again, when it comes to comms, it needs to be reliable. A lot of times comms is sometimes overlooked at the beginning of the design, but then once production is happening, it's a key component. When you hear Mike speak before or during the tour yesterday, Mike Bonner, you know, he's at 9 West, but his production crew is all the way on the other side. And they need to speak like they're in the same room. So it needs to be reliable, it needs to be flexible. So with our redundant dual ring fiber network, again, it's a large space here, so we needed to satisfy being able to place certain units in different areas within Notre Dame and the campus and make them all connect as one big system. And us having a distributed masterless system allowed us to do that without having one main system over here and then slaves. Every single one of our systems acts as a master no matter where it is, and then they connect over fiber. And this is a redundant fiber ring. So just in case one fiber does go down, everything can go back along that ring so that you do not lose communications. When we connect these different frames, you also have to make sure they're non-blocking so that whenever one person here wants to speak to another person there, that line of communication is always open. So you can keep connecting different frames in different locations within our system, and it just creates one bigger system. So no matter where these frames are placed, when you connect them over fiber, they just basically show up as one big coherent system. So it is scalable from 8 ports up to 1,024 ports, and up to 98 of these different nodes can be placed in one large network. Here we're using 3. Also, you know, it's not just about being able to communicate from a producer to a director or to a cameraman. It's also about integrating with the other people here and the other vendors and passing the audio from the comm system and over into the production system. So comms is not just for communicating, but these signals, we're taking the stuff that goes on air and we're actually bringing it for IFBs, so it needs to be very high quality. And we're taking commentator audio through our system and then putting it on air. So again, having an AES-3 backbone and having it digital end-to-end was very important for this. So the parts, another key thing that we look to as a company is that our philosophy is always built around standards. So our different interface cards, you know, we're actually using all of these except for AVB in this job right now. So Maddie, VoIP, AES-67, and also Dante. AES-67 was one of the key components. So the panels, the cards, as Brendan said, our wireless system, all operate on an AES-67 network. So one of the keys, like right now, we're using AES-67 for the audio portion, But I think in the future, goal is to move eventually into SMPTE 2110, where AES67 is the key audio component of SMPTE 2110. So that was very important. Also, what we'll be bringing on is NMAS, as you start going into and just putting things onto a network. You don't want to go from one software interface to look at maybe the audio, and then another one to look at the video, and another one to look at this. You want a single coherent system. So we have all the hooks in place for NMAS if they choose to use that. So it's one single location to look at all of your audio and video sources and actually conduct all those routes. And then also with AES67, with the way the campus is set up, the audio and the network needs to traverse through multiple subnets, and AES67 allows you to do that pretty simply. And then also using a common clock. So having the PTP version 2 clock being the main grandmaster clock to sync not just our equipment, not just our wireless, but the audio and the video systems as well. So the frames that we use, we offer 3 different frames, and Notre Dame actually used all 3 of these frames. They use our 128 ports frame, the 64 and the 32. The 128 and the 64 are both in the central control room or the central equipment room, and then the 32, I believe, is over at the Fighting Irish Media across the street here. And these are all connected, again, over that fiber backbone. The panel that we're utilizing here, as you saw through the tour yesterday, and you'll see it again through the tour today, at every station is one of our smart panels. The smart panel is from the ground up an AES67 and or AVB. Here, of course, we're using AES67 to make the connection of the audio, bidirectional, and the data back to our main frames. And what this allows, another key component, was having the system be future-proof. So these panels are built on an app infrastructure. So as their needs start to increase and they want to take advantage of different workflows, we pretty much describe this intercom panel as a user interface, because that's what it is. And it can take on different workflows, doing router control through Ember Plus. It can, we're looking at bringing on different VoIP apps where you can turn this panel into a telephone hybrid without having to put some type of VoIP or telephone hybrid card into the system or have an external third-party hybrid. So you'll be able to turn these panels into hybrids as well. So as their needs, as time goes on and different needs arise for Notre Dame, they'll be able to take advantage of these different apps that we're going to be coming out with without having to purchase new hardware and to create more space for more units in those locations. So they'll be able to either put multiple apps on a single screen or hit a button to change the whole entire workface of that user interface. And then the last part, and again, this was came up at the very tail end, as Brendan said. It was basically at NAB when we did the launch for Bolero, and when Scott came through and Fred came through and Brendan came through, they said, we want this. And of course, then we had to scramble, number one, to release the product, number two, to secure the product that they needed, because it had to fit within the production and the installation timeline that existed before this product existed. So we really had to convince a lot of people back in Germany to put them at the highest priority to get the product there. So Bolero is, again, it's a wireless system, but it operates in the decked frequency range. One of the big things, when you're operating in the gigahertz range is multipath reflections. So one of the key design aspects that we had to do with this is be able to overcome these multipath reflections, especially when you're dealing with stadiums and different changing venues where there's lots of metal and lots of different obstructions. You have to make sure that the path between the bell pack and the antennas is very secure. And we were able to do that with something we came up with called the ADR, which is a multipath receiver technology that can distinguish between all these different reflections, which is the best path from that bell pack to the antenna or the antenna to the bell pack. The antennas actually operate on an AES-67 network, so it was able to fit into the infrastructure that was already in place here and adapt to that right away. We were able, because of the ADR technology that we put in here and the antenna diversity, we were able to pretty much cover the entire stadium with one antenna. There are actually two antennas, which gives us a little bit more flexibility. So there's one high up in the scoreboard, and then there's also one down on the field. The field is covering pretty much the whole bowl area for all the camera operators and the technical staff that's walking around. And then the one in the scoreboard is actually hitting to 9 West and covering some of the tunnels and some of the upper areas so people can freely walk from the field up into the booth and still have coverage. Right now there's 8 bell packs for the camera crew and the technical staff. And again, this all operates over an AES-67 Layer 3 network. And then as an overview, this is pretty much an overview of the design, so the 3 different frames and all the different interface cards, the Dante cards, the AES-67 cards. We're using MADI in this as well. And I believe, are we using analog to get out to the trucks as well? So there's a little bit of analog in here. It's Dante, okay, excellent, excellent. And that's pretty much the Riedel system.
Excellent.
Thank you.
Great, thanks. All right, Vince, last but not least. So,
All right.
Evertz perspective.
Sure. So at the beginning of this project, many years ago, one of the things Scott and Dan made very clear to us, and Scott continued to repeat, was the system needed to be obviously future-proof, but adaptable, dynamic, and scalable. And while you did all those things, it still had to be really easy to use, because they had, novice people coming in using the system, students going to constantly turning over, and so that was a very key design constraint from the beginning, or I guess maybe a feature. So at the core of all this, if you will, the crossroads of all this, we put in an EXE28, which is a 23 terabit router. And I believe there's something like 1,152 10 gigabit ports that give scalability actually in the current configuration of HD at 1.5 gig, just shy of 7,000 squared video signals. And when it's 1080p obviously, or 3G, it'll be half that. So definitely got the scalability part there. And the router itself and the routing system itself is actually, as Brandon previously mentioned, it is Aspen today, but it will be SMPTE 2110 whenever I guess all the things line up right for it to be that way. But it is ready to be that way today. And as Brendan also mentioned, it's pretty much agnostic of all the various signals that can flow through there. So off that switch, there we go. There's the switching capacity. It's got a full complement of actually audio that can go through the audio switching matrix and all the Evertz multiviewers as well. So basically, you have one entire live media system being fed off of this one core. And the multiviewers as well, I should mention, are all IP based. Also hanging off this is a cluster of Dreamcatcher, a total of 36 captures or channels of record, 16 total channels of playback playout for that are scrubbable and slow motion. Actually, the few more there for actual just dedicated playout, and 4 operator stations currently configured with 4 more logging positions. And the interesting thing here is that this entire system, as I say, it's built in a cluster, so that capacity can be subdivided on an hourly basis, if you will. So if you've got 3 simultaneous events happening, the routing system, the media, the records, the operator stations, they can all be reallocated to support those 3 simultaneous events and then come together a few hours later for one large-scale event. So that's a really cool piece of this technology that not only the cluster technology enables, but just IP itself enables in terms of not having things to be rewired or rerouted. It can just be dynamic that way. Next, the whole Magnum operating system, which is pretty much tying all this stuff together from a control perspective and coordinating all this and orchestrating and managing bandwidth and operator positions. And what really brings it down to something as simple as that I have an event at 2 o'clock and it needs to run for this long, and provision these operator positions, and I want this signal to end up here on a simple router panel as we used back in the baseband days. This is what actually hides all that complexity in the background and stitches all the pieces together. It makes it look like a seamless surface for one system, and obviously can visualize the entire complex network graph and flows. So it's a powerful tool that basically makes the system simple to use. And then in addition to that, one of the big challenges as you move to a new paradigm, this IP paradigm, is you need different tools to troubleshoot and see what's going on or what's going wrong or what's going sideways or why something is happening. And the Insight tool, which is the next generation of monitoring tool from Evertz, is actually that. It's collecting data from all the access points at a very, very, very fine-grained level, whether it be logs or data streams. It's collecting it all and creating a bunch of tailored dashboards for the folks here to use and be able to aid in troubleshooting or hysteresis or check on utilization over time to see, do they need to add more bandwidth here, or do they need to add more equipment or whatever. So this is a really key tool to the whole system. You'll see this all on the tour. And so anyway, again, one of the key things to always that we kept coming back to as we went through this project, through the design phases and even the rollout, is again taking that big step back and realizing what this is really for. And it's not just for building just the stadium just for Saturdays. It's for the weekly events that happen more continuously, and that there's going to be a new group of people almost every year having to get their hands on the system and ramp up to it quickly, and that we don't know where the future is going to take us. And so that was the thing, that the system is capable now, whether they want to move to 4K, there's a lot of capacity there, or if it becomes HDR, it's ready to go now. Whether high frame rate cameras get turned on, like I've heard previously mentioned, there's no real changes to the system other than a little bit of configuration in that Magnum operating system, and everything else will just fall out from that. And so that's, again, we always try to take a zoom back to make sure we were completing those goals, and we have to continue to work with the amazing people involved in all this to see where, as they move forward, how it needs to adapt. And that's the piece that I know was really big and important from the folks here at Notre Dame from the very beginning. And so that's the core. I try to keep it quick.
That's great.
Core of Evertz's involvement here.
So real quick, because we have about 2 minutes left, and I want to get one question in. So you all kind of mentioned 2110. So let's say this project was not built now. It was built 2 years from now. 2110, what would that have meant as far as just the integration? Because there's a lot of people selling it off as a panacea for everybody's. It's going to make kumbaya and everyone's going to work together really easy, boom, plug and play. What's your sense on the myths and the realities of SIMD 2110 and how it would have made this project easier?
In terms of easier, I'll take the first stab of that. I suspect some of the interops and some of the timing, which, Brandon and I've had these conversations about timing, that probably would have gone a little bit smoother, for sure. Not that it went poorly, but it just would have been a little bit easier. And I don't know if 2110 would have made this particular project in this particular configuration any easier other than that aspect, because you got the benefits of IP, and when the protocol shifts, it's okay. I don't know if it would have made anything that much easier. Maybe Brandon has more insight there.
I would think that the one thing that I look at with SIMD 2110, besides for everybody being on board, is the NMAS, which he talked about. That was a little bit of a struggle, is that we're still using a lot of cloud devices and assigning multicast address to them manually, or firmware has to be written for them for drivers to integrate to the system. That's a little cumbersome. And Dante is a mature product, and you pull up Dante controller and all your devices say, hey, I'm here, you can route me from this interface. And if SIMD 2110 can bring that to the table in a production world where you can do it with video and audio and data, it's going to make things a lot easier.
Yeah, from the control side, I would agree with that, though. The whole NMAS initiative, I was kind of separating the two, but the NMAS initiative would have made this a lot easier, for sure, from a control.
Yeah, I think that goes for the consoles as well. I mean, if we had NMOS on board, then and Evertz had NMOS on board, stream recognition, that kind of thing, the consoles themselves would be more mature when it comes to dealing with multiple AES-67 streams in the way that it had to. And we had to do a software patch to make that work, to scale up to this project, and that would have been done. It would have been part of the roadmap. We're fully on board with NMOS and with SMPTE 2110. The audio stream itself is really not the issue. It's to do with control and connectivity.
Gotcha. Excellent. Great. Well, thanks, guys. Okay, we're going to do one more panel, and then we're going to start the tours and have some lunch. So thank you for your time, and congratulations on the projects.